Welcome. I'm Steve Graves, and this is Supply Chains and Manufacturing Systems: Planning. Today what I want to do is to give you an overview of the topic for the class, to talk about our learning goals, the intent of the class, to go over the class schedule, as well as the format of the class and the protocol. To start, what I want to do is to talk a little bit about what we mean by supply chains and manufacturing systems in terms of what's common and what's different. Let's start with a definition. So for supply chains, here's a definition. A supply chain is a sequence of processes that acquire, transform, and transport inputs into outputs so as to serve and satisfy customer demand. And as an example here, I've sort of mapped out a schematic of a supply chain for manufacturing shirts. We start with raw materials. We start with cotton. That might come from Alabama in the United States. That cotton gets transported, say, to Indonesia to get converted into yarn. The yarn goes someplace else to be made into cloth. The cloth goes to a factory, say in China, that manufactures shirts. The shirts then go to a distribution center, maybe for the brand or for a retailer. That might be back in North America. The shirts then eventually get to stores where they're sold to customers. So again, at a high level, this is an overview of what a supply chain is. It's a sequence of processes. Start with inputs, raw materials. We produce a final product. We serve customer demand. A manufacturing system is actually quite similar, but in some sense on a smaller scale within a supply chain. And here's a definition. A manufacturing system is a sequence or set of processes that transform inputs into outputs within a supply chain. And to see that, let's again think about our shirts, but let's look at the shirt factory. The manufacturing system here might start with cloth. The cloth might get colored. After coloring, it gets cut into patterns. The patterns get combined by sewing into a shirt. The shirt then gets finalized by some ironing and packaging, and out the back of the factory, we get a shirt. Again, it's a sequence of processes go from input to output. Very, very similar in some ways, but as I said, so the manufacturing system you think of as being within a supply chain, which is more broader. And that's going to be our focus for the class, is looking at supply chains, manufacturing systems. Sometimes we'll distinguish between them, sometimes we won't, but in all cases we're thinking about processes that transform inputs into outputs, quite often through a series of steps. What does planning entail? Well, when I say planning, it means determining what different steps, different processes within the supply chain or within the manufacturing system, what they'll do now, and what we plan for them to do into the future. And as we think of planning of a supply chain or of a manufacturing system, we've got different parts in terms of we've got procurement of the supplies of raw materials, procurement of cotton, let's say. We've got determination of a production plan for subsystems or for subcomponents. We've got determination of an assembly and test plans for the final products. We've got determination of the plan for distributing the product out into the distribution center, and possibly even determination of a plan for how the product will eventually get delivered to the customer. And when we think of planning, what we're trying to do is to determine for each of the steps, for each of the processes, either within the supply chain or within the manufacturing system, what it should be doing now, what it should be doing into the future, and to do that in an integrated and coordinated way, recognizing that each step is part of an overall system, and to do that as efficiently and as effectively as possible so as to match the supply coming from the supply chain or the supply coming from the manufacturing system, to match that supply with the customer demand. Why is this difficult? Why are we going to have a class? What are we going to focus on in the class? Well, I think there are really three important elements that make planning difficult for supply chains and manufacturing systems. First is just complexity. And the complexity of the system arises just because of the number of steps, the number of links, so forth. It's a complex system because there's many steps, many transformations that are going on. Secondly is uncertainty. There's uncertainty in demand. We can't exactly predict what the customers want. And there may be also uncertainty in supply, in terms of uncertainty in terms of the procurement of the raw material, or uncertainty associated with the process steps, the transformation steps that occur either in the supply chain or in the manufacturing system. And thirdly, it's difficult because of inflexibility. So associated with each of the processes are resources, and those resources can be inflexible. They can be inflexible just because they're limited in number. We only have so many cutting machines, or limited in the amount they work. We have so many people. They can only work so many hours per day. So they're limited, they're constrained. And that creates one element of inflexibility. The other inflexibility comes from the fact that many of the resources exhibit economies of scale. For instance, there may be setup activities associated with setting up the cutting machine to cut a pattern. And once we're set up, we've incurred that cost, then we want to produce a batch of goods. Or there can be economies of scale in transport, that once we've contracted for a truck to go from A to B, we've got the whole truck. We've paid for it, regardless of how much we fill it up. So there's economies of scale in transport too, and that creates another source of inflexibility. And so for these reasons, complexity, uncertainty, inflexibility, planning can be very, very difficult, can be very, very challenging in the context of supply chains and manufacturing systems. What's our intent and learning goals for the class? Well, first, what we want to do is we want to develop your understanding of the phenomena and the challenges that arise in these systems, to sort of help you think about these systems in terms of what's difficult, how to think about it, how you might address it. Secondly, we want to develop your toolkit of models and methods for planning these systems. And a lot of the class will be spent on introducing you for different ways of modeling, and particularly the inventories, as the inventories are used, are deployed throughout the system. And thirdly, what we want to do is to expose you to various tactics, concepts, and countermeasures that are very, very useful in managing and planning these systems and for dealing with the complexity that we discussed previously, in terms of the complexity from the system, in terms of the uncertainty, in terms of the inflexibility in the system. In terms of the schedule for the system, the schedule for the class, we have 8 weeks. This first week will be introduction. We'll talk about the systems, about the challenges, about how we think about modeling the system, how we think about planning the system, and what's to come. In the second week, we'll do demand forecasting. As I say, demand uncertainty is one of the major difficulties that arise in these systems. One way that we address that is we always will work with a demand forecast. So we'll talk about methods of forecasting and ways of measuring the accuracy of the forecast. The weeks 3 and 4, we'll talk about inventory models. I say the basic fundamental inventory models that are used both in supply chains and manufacturing systems for planning the inventories throughout the systems. As I said, each of these process steps does a transformation, takes input, which is inventory, transforms it into output, which is also inventory. And in some ways, in order to plan, to understand, to manage these systems, you need to focus on the inventory and the inventory transformations that occur throughout the system. And to do that, we have some basic inventory models, and that's what we'll do in week 3 and 4. In week 5, what we'll do is we'll apply these models in various ways so as to get a better understanding of some of the tactics for planning these systems, to get a better understanding of some of the countermeasures that are used, and to get a better understanding of how these simple models can be used to guide improvement activities. In week 6 and 7, we'll sort of start to look at the complexity in both supply chains and manufacturing systems by introducing multi-stage models. Basically, we'll take our inventory models that we've developed previously, which have been primarily focused on single stages or single processes, and show how to use these models to model a multi-stage and to plan a multi-stage system. And then finally, in week 8, we'll introduce and describe some real-world applications that will illustrate how the methods, tools that we've developed in the class, how these are used in practice and with what impact. For class format, every Tuesday, materials will be posted. That'll be a set of videos, maybe 80 to 90 minutes of videos. Each of the videos will have some finger exercises. There can be some readings. These readings are set up to complement the videos, and so you should, as you watch the videos, you should also be doing the reading. And then there'll be a problem set or assignment for at least weeks 1 through week 7 assignments. There's also an online forum available for you to post questions, to answer questions, to participate in discussions. And this is, again, a nice way for you to share your learnings with the other learners within the system. And I hope to create a community of learners as this class proceeds. Each assignment is due 2 weeks after posting. And then as a prerequisite, we've listed an undergraduate degree in engineering. And let me just clarify that. Ideally, you have an engineering undergraduate degree, but maybe more importantly, what we want you to have is to have basically an engineering mindset. And by that, what I mean is that you're a problem solver, you're comfortable with mathematical modeling, you're comfortable with the type of mathematical concepts that we'll use in the class, and that you have sort of, I would say, an analytic way of viewing these systems. More specifically, though, we're going to assume some base level knowledge of probability and random variables. And to convey what our expectations are, you should look at the problem set for week 1. That's basically the way that we're articulating what we expect you to know in terms of a little bit about probability, probability distributions, cumulative distribution functions, random variables, how to deal with expectations and variances, and particularly how do you deal with normally distributed random variables. So you should look at problem set 1 and make sure that you have that fundamental knowledge of probability and random variability and random variables. For grading, the grading will depend upon the assignments. There are 7 assignments. Each one will be worth 5%, so for a total of 35%. There'll be a final exam that'll be posted on July 31st. You have a week to do it. It'll be timed 3 to 4 hours. It'll be worth 65%. We'll combine the grades, and passing grades will be A, B, and C as denoted on this slide. So that's my introduction. Welcome to the class. We're very excited to proceed with this, to proceed down this journey, and I look forward to working with you over the next 8 weeks.